Hey guys, welcome to Unit 10, Section 1. We're going to talk about the basic formation of weather and how clouds are formed. So we need to start really quick with reviewing a little bit of topics as well as introducing some new stuff. So we're going to talk first about atmospheric pressure. Atmospheric pressure is basically the force of air in the atmosphere pushing down. So the closer you are to sea level, the higher your atmospheric pressure actually is. And that's just because you have more air pushing down on you. So Denver has less atmospheric pressure than most places because we are at such a high level. And a lot of atmospheric pressure will depend on the temperature, but most of it is depending on the elevation. Okay? Pressure is usually measured with a device called a barometer, and any major differences in pressure are going to lead to high and low pressure systems, and that's really where we're going to get winds across the planet. So we've talked about this stuff in the past. We've talked about some of those big Hadley cells and things like that and how they are affected by pressure. Now we're kind of looking a little bit more precise. Instead of looking on a global scale in terms of climate, we're looking more on a local scale in terms of weather. So when we look at these pressure differences, high pressure systems are usually going to be clear, low pressure systems are usually going to be rainy and stormy. So here's a diagram just to kind of get the idea of how we're referring to this atmospheric pressure, because if I say am existing right here I am, yay, okay, then that means that all of these all of these air molecules above me are pushing down on me. So that's the pressure of the atmosphere. And we don't really feel this unless it's changing. We notice that when we go up into the mountains, our ears pop because now, and when we're up in the mountains, we're at a different level. And so there's less air actually above us pushing down on us. So that's when our pressure changes. That's when we notice it. But in general, we don't notice the atmospheric pressure very much. These big differences in pressure and temperature essentially lead to the creation of air masses, and air masses are basically large areas of air that have similar properties, and they kind of move together. So when different air masses will meet with one another, they form what's called a front. That's a boundary that separates the two air masses. So if it's a warm front, what that means is that we have warm air moving into the area. So we would have a situation like down here. We have warm air moving into the area, and as a result, it kind of pushes on top of the cool air. It condenses because it's being pushed up. Cool air, of course, is more dense, so it's going to be kind of generally kept towards the bottom, whereas the warm air is going to be pushed up because it's less dense. So because of that density, we get the warm air moving on top of the cold air. It condenses, and we generally would get just moderate precipitation. Rain, not necessarily massive thunderstorms, but as a result of that gradual increase and that gradual flowing up of the warm air, we would end up with precipitation going down. In a cold front, we have a cold mass of air moving in, and the warm air that's already there, the cold air is trying to squeeze up underneath it. So what happens is it kind of rapidly pushes that air up. So we get this kind of quick movement of the air going up, and because it moves up violently and rapidly, it condenses, and that's where we are going to end up with thunderstorms or more severe rainstorms and things along that front. So usually when a cold front moves in, that's why we're going to end up with thunderstorms and stuff, because that air is forcing underneath, forcing all that air up very rapidly, whereas a warm front coming in is more of a gradual increase in altitude as it moves on top of the cold air. So the amount of moisture in our atmosphere is referred to as humidity. Warm air generally contains more moisture than cool air. That's just because as it warms up, the particles are going to spread out a little bit, so you can fit more moisture into it. When air cools, ultimately that moisture is going to come out of it. It may come out in the form of dew. It may come out in the form of clouds or fogs, or it may be heavy enough to actually form full-blown precipitation. Generally, when we're talking about precipitation, water vapor needs something to collect to. Water molecules, yes, they're attracted to one another, but they can be easily attracted to other particles as well. So any sort of dust particle in the air can start a snowflake or start a raindrop or start a hailstone. So what you end up with is movement of air within the cloud will actually determine the type of precipitation. So the temperature of the air as well as how much it moves within the cloud ultimately can determine the precipitation. So that may help explain why sometimes we actually get more hail storms, which are ice. We get hailstorms in the summer, even though you're like, well, wait a minute, it's warm outside. Well, remember at high altitudes, of course, we are above the freezing level. So when you're in a cloud and that cloud has been pushed up so rapidly, probably because of a cold front moving in, push that warm up air up super fast, you end up pushing that cloud above the freezing level, so things inside it can actually start to freeze. In the summertime, if you fly through a thunderstorm, there's actually snow in there, but that snow melts before it reaches the ground because of the temperature of the air closer to the ground. So hail forms usually when a frozen particle is forced to kind of move up and down repeatedly, and every time it moves up into the freezing layer, the water kind of coats the outside of it, and then it moves down, it melts slightly, it moves back up, the water freezes that outer layer again, adds more water to it, so you continue to add layers. If you cut a piece of hail in half, you generally see that it has layers on the inside of it. So I know many of you learned this stuff earlier in your educational career, but I just wanted to do a quick review of the three major types of clouds. Cirrus clouds are the ones that are going to be very high altitude. Those are the ones that usually look wispier. Generally, they're made out of ice crystals, so they're above the freezing level, so all the water is actually frozen. Cumulus clouds are your happy-go-lucky, bubbly clouds. Those are your fun, rounded ones, the ones that we associate with fair weather, ones that we like to see. And then stratus are the ones that essentially kind of blanket the whole sky. They may completely blanket it and it goes fully gray, or you may have some peeking through of the blue behind it, but the idea is still there. It's kind of the no distinct area to notice between the clouds. There's a lot of different cloud types that also form based on altitude, temperature, etc. So when fronts move in, you may get cumulostratus or cumulonimbus or cirrostratus or cirrocumulus or whatever. So you get a lot of combinations of them just kind of depending on the altitude. But these are the three major types. You have your blanket type, blanket, okay? You have your cotton ball, and you have your wispy, okay? Your wispy or your kind of feather clouds. So just a reminder that all of this stuff has to do with density, has to do with temperature, has to do with precipitation. Well, precipitation is a lot of time a product of that. But the idea here is that we're always dealing with moving of air, warm air rising, cool air falling, etc. And as it does, water just kind of is along for the ride. And if it gets into cool air that becomes more dense, then the rain falls out of it. So we see that warm, moist air moves up over land, and then rain can kind of fall out of it and fall down as it precipitates. So that's what precipitation is, okay? So these are the basics of what weather is about. Starting next class, we're going to start a little bit more into some of the specific types of weather, as well as some of the other issues that are kind of associated with that. So you'll see where we're going from here, and I will see you then.